Let's try to understand recursion. I have also explained Fibonacci series solution in logic building playlist, so you can go there and watch the video. And if you have not good understanding on recursion, then you can come back here. So this is going to be a long video, but I'm going to explain this recursion in a depth, and I'm going to use the golang for the solution. So let's start with this. Okay, so I'll write the code, and along with the code we'll understand the recursion concept. I'll give you basic examples and we'll go from there. Okay, so the first thing, I'm going to print like 1 to 5, and I'm going to write the program for this. So just let's see, I want to print something like 1, 2, 3 and 4 and 5. So we'll understand the basic concept of the recursion for this program, and then we'll write another program and we'll try to understand some common pattern in recursion. Okay, so I'm going to call some function, like I can say, okay, print n. So n is, let's say it's a 5, so n equal to 5. I want to print 1 to 5 here. So the logic I'm going to write here, func print n. That's all. Okay, so we know the recursion, when in a recursion we need the exit condition. So n is 5 and we want to print the 5. So let's print this, print let's import first fmt, and then we can print this fmt.println, and then we can print n. So this is the 5. So we printed 5 here, but we do not want to print just 5. We also want to print 1 to 4. So here we need to have faith. So some faith, like if I call some function fn-1, then it's going to print 1 to 4. So we printed 5 and this function is going to print 1 to 4. So 1 to 4 here, and then the 5. So this is the faith, and we printed here, and we need one exit condition, like if n equal to 0. So we are calling the function if n-1. So it's a 5. It's a 5. Now it will be 4. Next time again it's a 3, 2, 1, and sometimes it returns, it becomes 0. So in that case we just want to return from there. So that is the exit condition. So we saw like main things here. One is exit condition, and we need some faith. So the faith is based on some pattern. So we'll find the pattern, and then we have faith, and we'll call the function, and we'll get the result. So let's run this, and again we'll try to understand. So the function is print, so we have to give here print. Now we can see 1, 2, 3, 4, 5. So and also, if you want to understand in detail like how it's happening, then you can just start with a small number. And I say in a small number, I always, or most of the, I say that most of the time I choose 3. So if I start with 3, and then let's see how it's working. So if I say f3, then we'll have some exit condition. If n equal to 0, no, it's a f equal to 0, return 1. So it's not 0, then we can call another function f n-1. So n is 3, so that will become 2, f2. So we'll call this function, but here we also printed n. So n is, we printed 3. 3. We printed this n and we call this function. So before printing this function, we call f2 here, f2, and then we call f2, then again logic will call this f2 from the beginning. Again it will check it's a if the value is 1 or value is 0, then it will return, but it's not 0, then so f2 will call again. Let's give me the pipeline here so it will be understand. So this f2 will call f1, and it has to print something here, like it has to print 2, but it didn't print 2, but again the f1 call another function, that's a f0. So we'll come here, and it will call f0. So now if it call f0, then we have the exit condition. If it's a 0, then it will just return. So yeah, so it will f1 and f0. So here, but before calling the f0, we are also printing n, right? So n is 1 here, printing 1. So we know this f0 will return from there. So if you return, then this function is done. Then remaining portion was 1, so it's a print, it will print 1. Then again this is done, then it will print 2. Again this is done, it will print 3. So in this way it will print 1 and then 2 and 3. So if you want to understand for any kind of recursion, take the small number and you can see this kind of thing. But I do not do a lot of these things nowadays, because I just work on this exit condition and do the faith and print these things, and that's always going to work. So this is a very basic example of this recursion. And so in the similar way, we also did a program for the Fibonacci. So let's do the Fibonacci series once again here. So in the same way, if you think for the Fibonacci, let's say for 3. So for 3 we want to print the Fibonacci. So we know the 0 plus 1 2. So 0 plus 1 1, it should be 1 here, 1 0 1 1, and then 1 1 2. So we want to print this number. So let's say here I say the if for the Fibonacci, and I'll pass 3 here, and then if we need the exit condition. So we know how to calculate this Fibonacci. So what we are doing, if it is a 2, then we're saying n minus 2. So 2 minus n minus 2 minus 2, so 0, and then 2 minus 1 1. So we're finding that logic. So it's like 3, let's say 3. So f3 is f minus 2 1 plus f minus 1 2. So that's pattern we have found here. Like if I calculate this 3, then how I'll do f n minus 2, that is 1, plus f n minus 1, that is 3 minus 1 is 2, so f2. So I need this logic here. And we also know the exit condition. So if n equal to 0 or n equal to 1, then in that case return n. So here there should be something, return n, and let's print this, println fn. Okay, and we can call the function, and if that function is fn minus 2 plus fn minus 1, and this is the result. We can store the result and we can return this result. So First run this and then try to understand this. Result return. Okay, so for the 3 it's a Fibonacci is 2. So we can see the similar pattern here. The pattern is the exit condition, and exit condition is if n equal to 0 and 1, then return that number. So that's the exit condition, and that's a belief. Like we know, if I have Fibonacci number of n minus 2 and the Fibonacci number of n minus 1, if I have these 2, then I can have the Fibonacci number of 3, and we can return this result here. If you want to print that value, we can print also here, like let's say empty print ln, and then we can print n in case of 0 1, and we can also print this result. Let's see. So 1 0 1, so maybe, yeah, so you can understand this logic anyway. So you can print here, you can print the before and after and see, you know, the behavior of this, how it's getting called. It's not a result, I think. Yeah, result should be here itself. Yeah, because we cannot define. Okay, so that's all. And if you want to use the memoization, you can always use the memoization to reduce the call. And we can see that how to use the memoization. If you can store this result somewhere in the memory, and if you find the same result, just return the result but do not call the function, and that's a memoization. So for that, like let's say I'm going to have one memory here. It's like one map. So create the map. It's int and int, and pass this map here m. So this is also need a variable m. So map int, and what I'm going to do here is, first thing is, before returning the result, let's store this result in a memory. So m and n, and the result, I can store the result here. And I can also check if I find the result stored somewhere in memory, then I can return that, and I will not go further. So I can check if okay mn, if okay. So if that means if that result is found, if okay, then return v. Yeah, let's run this. If n minus 2, here we have to pass this memory block. Okay, so we got that result. So let's not print this and print something here, like fmt print ln, see memoization is working. So for the small number, we do not see that function is getting called again and again. But if you have like some big number, like let's say 5, memoization is working, and also print like which result we stored. So for n, it's n. This would be comma. Okay, so see, memoization is working. It's working. It's working. Okay, memoization is working for 2 and 3, because we call 2 and 3 function, you know, in memoization one more time. So let's see how we call this. So let's say here I'm calling f5. So if I call f5, then it will call fn minus 2. So fn minus 2 is 3, so it will call 3, and plus it will call f minus 1 f4. Again when we call f3, so f3 will call f minus 2, that is f1, plus fn minus 1, that is f2. And for the f4, if you call f4, then f4 will call fn minus 2, so that's f2 plus f3. Okay, so if you see here, the f1, f2, yeah, f2 is getting called here, and f2 is also getting called here, f3 also getting called here, f3 also getting called here. So that means the same function we are calling again and again. So in this case, we know if you call this function more than one time, then the good idea is, store that result somewhere in memory. And if you find the result, return the result. So this is like returning the result, and here storing the result in a memory. So this is called memoization, and this is also called dynamic programming. So we'll see many recursion problems, and we'll follow the same strategy. So I will check there the basic condition, and then I will check for the memoization, if I can use the memoization over there or not, and I find the pattern, and based on the pattern I just have the faith that like n minus 2 is going to return that result, f minus 1 will going to return the result for that particular number. So that same the exit condition faith we are going to use for the recursion, and if there is needed, and we'll see that there are multiple function call, same call, we can store the result of some function, then we can use memoization. So that is all about this recursion. And okay, yeah, so that's all for today, and we'll see another recursion problem in the next video. Thank you.